Hello friends, I welcome you all to my channel. I am very happy to see you all through this video. In the previous class, you have learned about the polymers and how the polymers can be classified. What are the polymers? What are the homopolymers? What is synthetic polymers? What are natural polymers? And how they are classified. In this class, you are going to learn types of polymerization reactions. Types of polymerization reaction. In general, the polymerization reactions can be classified into two types. First one is addition polymerization or chain growth polymerization. Reaction. The second one is condensation reaction or step growth polymerization. Condensation reaction or step growth polymerization. Step growth polymerization reaction. In this class, you are going to learn addition or chain growth polymerization reactions with some examples. In general, the addition or chain growth polymerization reaction, same monomer or different monomer add together to form the desired polymers. First, addition polymerization reaction, addition or chain growth polymerization reaction. Okay. In general, in these types of polymerization reactions, same monomer, already I told you what is the monomer. These same structural unit or repeatedly highly reactive units can be introduced in these polymerization reactions, and some unsaturated compounds. Okay, unsaturated compounds could be used in these types of reactions. For example, alkenes or alkadienes and their derivatives will be introduced to form the desired polymers. Okay. The first one, case of addition polymer chain polymerization reaction, same monomer or different monomeric species will be introduced during the reaction to form the desired polymers. Second, unsaturated compounds will be used. For example, alkene or alkadiene and their derivatives will be used. Okay, chain length or chain growth can be takes place through the formation of chain via free radicals or ionic species. Okay, these chain growth or polymerization reaction can be takes place through the free radical formation or ionic species. Okay, now we are going to see the free radical formation reactions with the help of some examples. Ethane to polythene reactions, how the free radicals help us to get the polythene via free radical reaction. Okay, free radical polymerization reaction. How the free radicals can be generated during the reactions, for which we need to add some catalyst. Okay, catalyst, for example, benzoyl peroxide, tet-butyl peroxide or acetyl peroxide. Benzyl peroxide, second acetyl peroxide, third tet-butyl peroxide. These compounds in general can be used as a catalyst or free radical generating initiators. What is the role of this catalyst, benzyl peroxide or acetyl peroxide, tet-butyl peroxide? The role is free radical generating initiators. Okay, free radical generating initiators. Okay, these compounds can be used as a free radical generating initiators, or it can be used as a catalyst to carry out the reactions. Okay, in the free radical formation reactions, in general, three steps were involved. First one is chain initiation step, chain propagation step, chain termination step. Three steps were involved in these free radical polymerization reactions. Okay, first, chain initiation step. Chain free radical formation. Okay, the first step is chain initiation step. Okay, chain initiation step. First step, we are going to add benzyl peroxide. Okay, benzyl peroxide as free radical generating initiator or catalyst. Okay, now we are going to prepare ethane to polythene via the free radical formation reaction. Okay, ethane to polythene reaction we are going to see via the free radical formation reactions. First we are going to take benzoyl peroxide. What is the formula of this benzoyl peroxide? C6H5CO C6H5. This is the formula of benzoyl peroxide. Okay, benzoyl peroxide. Okay, now the free radicals can be generated in the first step, chain initiation step. Free radical will be generated. Okay, how the free radicals could be generated in the first step? You can see here oxygen bond, carbon bond, carbon hydrogen bond. Okay, which one has the weakest bond and which one will be breakable? Very easy. In this case, the oxygen bond is the weakest bond, where the homolytic bond efficient can be takes place due to the weakest bond, and it can be easily breakable. So that homolytic bond efficient can be takes place in oxygen bond. Okay, not in the case of carbon hydrogen or carbon bond. Okay, the homolytic bond efficient can be takes place oxygen bond. Homolytic bond efficient can be takes place here. This is because of enthalpy. Okay, if you see the enthalpy of oxygen bond is 146 kg mole minus 1. For example, the enthalpy of the carbon bond is 346 kg mole minus 1. The bond enthalpy for carbon hydrogen is 412. Due to the difference in the enthalpy for this carbon bond, the oxygen bond can be easily breakable. So the homolytic bond efficient can be takes place here and form the bigger free radicals. Okay, bigger free radical. Okay, here the bond is breaking and form the free radical C6H5CO. This is the bigger free radicals formed in the chain initiation step. And further, it form phenyl radical C6H5 phenyl radical. It form phenyl radical in the chain initiation step. Next, this phenyl free radical is reacting with ethane molecule available in the reaction. Okay, this phenyl free radical reacting with ethane forms the another bigger free radical. I am showing here C6H5 CH2. This is the another bigger free radicals formed in the chain initiation step. Okay, next we are going to see chain propagation step. Okay, this half arrow is indicating the homolytic bond efficient can be takes place in oxygen bond. Okay, it's the weakest bond and it can be easily breakable. Okay, when compared to the other bond present in the molecule. Okay, next we are going to see chain propagating step. The final free radical is reacting with another molecule which is available in the reaction system and forms. This is the final free radical obtained from the chain initiation step. C6H5 chain propagation step. Chain propagation step. We got the C6H5 CH2. This is the free radical we got from the chain initiation step, which is further reacting with ethane molecule. Okay, and form, this is monomer molecule is alkene, and form the bigger free radical called C6H5 CH2 dot. This is the another bigger free radical. This process can be takes place continuously. This process can be takes place continuously, and the form the active free radicals replaced by another molecule. This is then active free radical is formed C6H5 CH2N CH2. This is active free radicals replaced by another molecule. This is active free radical replaced by another molecule. Okay, these active free radicals combined with another molecule and to form the desired product in the chain terminating step. Okay, next we are going to see chain terminating step. Chain terminating step is very important step in the polymerization reactions, where actually the desired polymers are formed. Okay, chain terminating step. Chain terminating. Okay, chain terminating step. In the case of chain propagation step, we got the bigger free radical molecule reacting with another bigger free radical molecule available in the reaction systems and form the desired compound. Okay, C6H5 CH2 CH2 reacting with another molecule available in the reaction. Okay, and form the desired molecule. Okay, what will happen here? C6H5 CH2 N CH2 the final compound can be obtained after the terminating step. Okay, in this class you have learned how the free radical polymerization reaction can be takes place in the reaction of ethene to polyethylene reactions. I have explained the detailed mechanism with examples. Thank you so much for watching this video. If you would like to watch my video in future, don't hesitate to subscribe our channel. Okay, if you really like my videos, please give your comments about the video, which will help us to give more quality video in future. Thank you so much friends for watching this video.